Hi everyone, welcome to my YouTube channel. In this video, we will break down the key differences between filters and interceptors in Spring Boot. We'll explain when to use each one and give you real world examples so you can confidently choose the right tool for your project. Let's dive in. In this video, we are going to cover everything you need to know about filters and interceptors in Spring Boot. First, we'll understand what filters and interceptors actually are. Second, we'll look at their use cases, when and why you should use each one. Third, we'll talk about the main purpose of using filters and interceptors in a Spring Boot application. Then we'll move on to the code level, where you'll see how to implement both with simple examples. And finally, we'll wrap up with a clear comparison table that highlights the key differences between them. Let's get started. So, what exactly is a filter in Spring Boot? A filter is a component based on the Java Servlet specification, specifically the JavaScript Servlet.filter interface. It works by intercepting incoming HTTP requests before they reach the dispatcher servlet. Filters can modify both the request and the response, making them perfect for tasks like logging, authentication, setting request encoding, or adding custom headers. In short, filters act as a gatekeeper at the very beginning of the request lifecycle. Let's understand a filter with a real-life example. Imagine you're entering an airport. Before you get to your gate or the boarding area, which in our case is the controller, you must go through security checks. The airport security verifies your ID, checks your bags, and ensures everything is safe. That's exactly what a filter does in a Spring Boot application. It acts as that security checkpoint, sitting right at the entrance of your app. Now let's talk about interceptors in Spring Boot. An interceptor is a component provided by Spring itself through the handler interceptor interface. It allows you to intercept HTTP requests before and after they reach a controller method. To understand interceptors better, let's look at a real-life example. Imagine you're attending a conference. After you enter the building, which is like passing through a filter, you head to the registration desk right before entering the main session. Here, a staff member checks if you are on the guest list, gives you a name badge, and maybe a welcome kit. After the session, other staff member might collect feedback. This process, checking before and doing something after, is exactly how an interceptor works in Spring Boot. Now first, let's discuss the normal request flow without any filters or interceptors involved. Imagine a client wants to fetch some data from the database. So what does the actual flow look like? The client sends an HTTP request. This request first hits the dispatcher servlet, which is the front controller in Spring MVC. The dispatcher servlet then decides which controller should handle the request based on the URL and the mappings. Once the appropriate controller is found, the request is forwarded to it. The controller then calls a service, and the service layer communicates with the repository, which talks to the database. After retrieving the data, the response flows back in reverse, from repository to service, service to controller, controller to dispatcher seller, and finally, the response is sent back to the client. This is a typical request response cycle in Spring Boot, clean and straightforward with no filters or interceptors in between. Now, what happens when we add filters and interceptors to our application? Let's walk through the updated request flow. This time when the client sends a request, it first goes through the filter. Don't worry, we'll explain the full purpose of filters and interceptors in detail later, but for now let's just focus on the order of execution. So the filter processes the request first and then passes it to the dispatcher servlet. Next, the dispatcher servlet forwards the request to the configured interceptor. After the interceptor does its pre-processing, the request finally reaches the controller. From there, the flow continues just like before. Controller talks to service, service talks to repository, and data is fetched from the database. Now on the way back, the response travels in reverse, from repository to service, service to controller, controller to interceptor for post-processing, then back to the dispatcher servlet, and finally through the filter before reaching the client. So now both the filter and interceptor have a role in processing both the request and the response. Now you might be wondering, what's the actual purpose of using a filter or an interceptor? Let's talk about when and why we use them. We'll start with the main purposes of using filters and interceptors in a Spring Boot application. 1. Logging. Logging helps you track every incoming request and outgoing response. You can log the request URL, IP address, HTTP method, or even how long the request took to process. This is super useful for debugging, monitoring, and analyzing your application's behavior. 2. Authentication. Before a user can access secure endpoints, you often need to check whether they are authenticated. A filter or interceptor can validate tokens, sessions, or credentials before allowing the request to continue. If authentication fails, the request is blocked immediately, even before reaching the controller. 3. Compression. Compression reduces the size of your response data, like converting large JSON or text into a compressed format such as gzip. This improves performance, reduces bandwidth usage, and speeds up the response for the client. Filters are usually used here to wrap the response before it's sent. 4. Coarse headers. Coarse stands for cross-origin resource sharing. If your front-end and back-end are on different domains, browsers block requests by default. A filter can add coarse headers to the response, like Access Control API Origin, to allow cross-origin requests and avoid coarse errors. Now, let's look at the common purposes of using interceptors in Spring Boot. Request logging. Just like filters, interceptors can also be used for logging, but with more context. Since interceptors operate at the Spring MVC level, you can log things like the controller method being called or any specific annotations used. This gives you deeper insight into what's happening inside the application. 2. Authorization. Interceptors are ideal for handling authorization logic. Before a request reaches the controller, you can check if the user has the right roles or permissions. If not, you can stop the request right there. No need to clutter the controller with access checks. Interceptors can also be used to change the locale or UI theme dynamically based on the request. For example, if a user selects a different language or theme preference, an interceptor can detect that and adjust the view rendering accordingly. These use cases make interceptors powerful tools for controller level logic without touching the controller code itself. Let's look at a simple example of a filter in Spring Boot. Here we have a class called myFilter that implements the filter interface. The main method to focus on is toFilter. This method is called every time a request passes through the filter. Inside toFilter, the first line prints before request in filter. This happens before the request is sent further down the chain. Then chain.toFilter request response passes the request and response to the next filter, or if there are no more filters, to the dispatcher servlet and ultimately to the controller. After the request has been processed and the response is coming back, the next line prints after response in filter. This means that code runs after the controller has handled the request. This simple example shows how filters can run code both before and after the request hits your controller, making them perfect for tasks like logging, security checks, or modifying the response. Now let's look at a simple example of an interceptor in Spring Boot. This class myInterceptor implements the handler interceptor interface, which allows us to intercept requests at the Spring MVC level. The first important method is prehandle. This method runs before the controller method is executed. In this example, it simply prints before controller in interceptor. Returning true here means the request will continue to the controller. But if you return false, the request processing would stop right there. The second method, posthandle, is called after the controller has processed the request, but before the view is rendered. Here it prints after controller, before view render. This shows how interceptors give you hooks both before and after the controller logic, letting you add features like logging, authorization checks, or modifying the data sent to the view, all without changing the controller code itself. We've already covered all the key differences in detail. Now, here's a quick summary in a table format. Feel free to pause the video and note down each point for your reference. Thanks for watching. I hope you found this video helpful and learned something new. Don't forget to like, share, and subscribe to the channel for more upcoming videos on interview question preparation. Got any questions or suggestions? Feel free to drop them in the comments below. See you in the next video.